Hey everyone, I hope everyone had a, a nice weekend. Excuse me. Excuse me. So, as a reminder, there is homework and a quiz on Lumen Learning. The dates are there as well, the due dates, that is. The first test is going to be next week. So what I'm thinking is it will be on everything I cover up to until the end of this week. And I expect to cover the last thing of factoring today and Wednesday. And then I'll start square roots, which is on Friday. So what I expect the exam to be on is basically everything we've done up until including this Friday, which I expect to be everything up to including factoring. Okay? So that's what I think the exam will cover. And it might, again, it depends how far I get on Friday. I'm thinking it might cover square roots. I mean, square roots, there's not too much we do with it in this class. But again, that's what I think is going to happen, though. So polynomials, of course, will be on the exam. All right, so we have that. Let me think the exam. Oh, and again, tomorrow, I know we don't meet tomorrow, but tomorrow is technically a wellness day. Excuse me. And I've heard from some faculty that I don't think we don't have office hours on tomorrow, but again, I will let everyone know for sure what I'm gonna do. You can always email me, of course, if you need help, okay? I mean, whether I'm available or not, you can always email me. I'll be more than happy to help you. If you do email me about something on Lumen, please use the message feature, because then I can see what the question is you're working on. It makes it easier for me to answer your question. Now, are there any questions at all? I did email the notes, and I think I posted, I did post the lecture videos from last class from Friday. They're on YouTube. Okay. And all the notes are on Blackboard, so. All right, let's keep going then. I'm hoping to do a worksheet today, but we will see. We're going to be back in factoring trinomials. Okay, so here, okay, we're going to be, again, if you can't see the slides, just let me know. I did email these to everyone. So basically now what we're going to do is we're going to factor trinomials now. Before, what we did remember was we factored trinomials of this form where the leading coefficient, the A, is 1. That's what we have seen already. And that was pretty, it wasn't terrible. Now we're going to consider, though, the case when the leading coefficient is not 1. You can actually do this method when the leading coefficient is 1. It's just more work than necessary. Here, though, we're going to see what happens if the leading coefficient is not 1. Okay, so what do we do? Well, of course, it's really good to factor out the GCF. I mean, it's technically not part of this procedure, but really, if you really factor out the GCF first, that's really a good thing to do. Now, what you do want to do, though, is this. You want to find two integers whose product equals A times C and whose sum is B. So basically, you're going to take A and C. C is the constant term. You're going to multiply them together. And then you want to find two integers whose product equals A times C, but the sum has to add up to B, the coefficient of X. We'll do examples, don't worry. And what you're going to do is you're going to replace B by that sum of those integers that you found in 2. And then you're going to have to apply this wonderful technique we love, factor by grouping. Okay. So you will have to use factor by grouping. I mean, there are other techniques people use when factoring these. This is the one I'm showing. I mean, I know it's tedious, but to me, the idea is pretty straightforward. At least I think it is. So also, factor by grouping is a good technique to know. So you're getting more examples of factor by grouping here. So this is the process, okay? Now, when I do these, I will always factor out the GCF first. That's what I do. Okay. All right, so that's our so-called AC method. So let's do some examples. So let's say we wanted to factor this first. Okay. Now notice the GCF is 1. Now how do we know that? Well, for 1, there's a non-zero constant term, right? So we can't factor out x at all. Okay, good. Also, what about the coefficients and the constant term? Well, we have seen already that 5 and 2, the only common factor among them is 1. So the only possible common factor among 5, 11, and 2 can only be 1. So the greatest common factor of the coefficients and the constant term here is just 1. So the GCF altogether is 1. I mean, hopefully by now you can see here, even though I just explained it, why the GCF is 1. 11 actually is also, just like 5 and 2, a prime number. That is, the only factors of 11 are 1 and itself. Okay. Now, okay, so next we have our trinomial. We have ax squared plus bx plus c. Remember, that's what we're factoring here, right? That's the kind of thing we're factoring. A here is the leading coefficient, which is 5. B is the coefficient of x, right? So B is 11. C is the constant term, which in this case is 2. So C in this case is 2. So A, again, just by comparing terms, 5x squared, so A is 5. B is the coefficient of x, which is 11. C is the constant term. So what's A times C? That's 10, right? B is 11. So we want two integers whose product is 10, but the sum is 11. Now, I did write the answer. So we want two integers whose product is 10. The sum is 11. And of course, here I wrote down 10 and 1. Now, is that going to work? Well, yeah, because 10 times 1 is 10. 10 plus 1 is 11. So 10 and 1 are going to work. Okay, so 10 and 1 do work. Remember, if the first choice you make doesn't work, don't panic, just try something else. If for some reason, let's say you tried 5 and 2, well, the product is 10, but 5 and 2 are not going to work because the sum is 7, which is not 11. Okay. So 10 and 1 work. What we do, as in the general method on the first slide, we're going to replace 11, our b, by the sum of the two integers in the trinomial. Now, what's going to happen here? Well, here's our trinomial, right? What we're factoring. We're going to replace 11 by 10 plus 1. Notice what I did here. I use parentheses, okay? Remember, 11 is being multiplied by x. So this entire sum is being multiplied by x. So now what do we do next? Let me get the wonderful PowerPoint pen. We're going to distribute, as you can see. So we're going to get 5x squared plus 10x plus x plus 2. Okay? That's what we're going to get here. So again, I replaced 11 with the sum. Okay? But remember, you want to distribute this x. Okay? You don't want to have just 10 plus x. You want 10x plus x. Well, 1x, but again, 1 as a coefficient we really don't write. But we end up with this. But now notice we can use factor by grouping. And why can we use that? We have 4 terms here. We have 4 terms. Okay? So we're going to apply factor by grouping. I'm not sure why this is here. Let me get rid of that. Oh, no, okay. Actually, I take that back. With factor by grouping, you know, really you do want to see if you can find the GCF. I mean, we already said that 2 and 5, their only common factor is 1. Not to mention we have 1 as a coefficient. Okay? So that tells us that the greatest common factor among the coefficients in the constant term, you know, the greatest common factor there is 1, and there's a non-zero constant term. So that GCF has to be 1 then. You know, you get B is 1, M is 0, right? Non-zero constant term, the smallest exponent of x is 0. So B is 1, M is 0, which is 1 times x to the 0, which is 1. Okay, so what do we do next? We make 2 groups of 2, right? In factor by grouping. And before we do that, let me pause the video.